So in this lesson, we want to describe variation. We also want to look at the notation and the constant of variation. We want to know how to write variation mathematically and how to get what we are calling the constant of variation. We will later on look at direct variation and solve problems involving direct variation. So we'll start with talking about or explaining or describing variation. So in mathematics, variation describes relationship between two variables or more. So you have come across different variables in, say, physics. You want to know what kind of relationship does voltage or current exhibit. When you're looking at business, you want to look at how costs will be affected by time. Maybe you are looking at it from a perspective of a rental property. So you might want to relate these two. The longer someone stays in a rental property, the higher the costs are in that regard. So variation will describe the relationship between two or more variables. And under variation, we want to talk about different kinds of variation. We have different kinds of variation. We have direct variation, we have inverse variation, we have joint variation, and we have partial variation. So we want to talk about these in this topic. So let us start with looking at direct variation. Okay. Okay, so in a direct variation, as one variable increases, the other variable also increases. We would also want to look at the graph that represents this type of relationship. So, like I said, we have looked at the x and y axis. Where they meet, that's the origin. So in this kind of variation, when one variable increases, the other increases. In this case, if the x variable increases, we also expect the y variable to increase. So if the x variable increases by 2, we would expect the y variable also to increase. If the x variable maybe increases by 4, from this graph you can see that the y variable will also increase. So this type of relationship is what we're calling a direct variation. So like I said previously, as the x increases, the value of y will also increase if we're looking at it from the perspective of the x and y variables. So that kind of relationship is a direct variation. How do we express this type of relationship? So this is where notation comes in. How do we how do we express this type of relationship mathematically? So there is a symbol that we use. So we would say y varies directly as x. So this symbol here means varies directly. The symbol means varies directly. Would also want to express this type of relationship in equation form. So if we want to express it in equation form, this will imply that y will be equal to kx, where k is a constant and this constant is greater than 0. So this k, which is a constant, is what we're calling the constant of variation. So let's see if we can look at some examples. Example 1 reads, given that y varies directly with x and y is equal to 8 when x is 6, part A requires us to find the constant of variation. Then part B requires to find the value of y when x is 3. Part C requires us to find the value of x when y is 24. So we will start with part A. So to find the constant of variation, there is this phrase in the question which is saying y varies directly with x. We know that this is a direct variation we're dealing with. So we can write it in notation form as y varies directly with x. This implies in equation form that y is equal to kx. We have to make k the subject of the formula. So this term goes to the left hand side, this term goes to the y goes to the right hand side of the equal sign. We divide both sides by x. So what we're going to have is an expression where k is the subject of the formula, and that's what we want. K is equal to y over x. So when we look at the question is saying y is equal to 8 and x is equal to 6. We substitute these values in there. So k will be equal to 8 over 6. Y is 8, x is 6. We have to leave our answer in lowest terms possible. So we find a highest common factor. The highest common factor will be 2. 8 divided by 2 is 4. 6 divided by 2 is 3. So we have 4 over 3. So k will be equal to 4 over 3. We can leave this in decimal in decimal numbers or mixed numbers, but I prefer we leave it in this form. So we are done with part A. We go to part B. Find the value of y when x is equal to 3. We have a general equation right here. So what we need now is to have an equation that represents this situation. We already know what the constant of variation is. The specific value is 4 over 3. So we substitute this 4 over 3 in this general equation to get 4 over 3x. This is the equation that represents the situation that is prevailing in this example. The next thing that we need to do now is to substitute in the 3 because we want to find the value of y when x is 3. So we'll substitute. Where there is x, we put 3. So 4 over 3 multiplied by 3 which is the same thing as just saying 3 there 1, 3 there 1. 4 times 1 is 4. 4 divided by 1 will just be 4. So our y will be equal to 4. Part C. Find x when y is equal to 24. We already have an equation for this situation, which is y is equal to 4 over 3x. So what we need to do is make x the subject of the formula. So we're going to take this term, which is 4 over 3x, on the left-hand side of this, and the y goes to the right-hand side. We need to multiply the left-hand side with a multiplicative inverse of 4 over 3, such that we remain with just an x. So the multiplicative inverse is just 3 over 4. So when you multiply this, don't forget to do the same on the other side of the equation. We're multiplying 3 over 4. 3 over 4 on the left-hand side is multiplied, and 3 over 4 on the right-hand side is also multiplied. So the whole idea is to just have 1. So x will be equal to 3y over 4. Now the question wants us to find the value of x when y is 24. Where is y? You're going to substitute it with 24. 4 there 1. 4 into 24 divided by 4 will give us 6. 3 times 6 will give us 18. Therefore, x will be equal to 18. That is that about, for this particular problem. Let's go and let's work out the last problem. Okay, so before I can work it out for you, you need to pause the video, try it out, and verify your answers as I work it out with you. All right, let's start with part A. So in the question reads, if A varies directly as B and A is equal to 12 when B is 15. Find part A, an equation connecting A and B. Part B, the value of B when A is 20. So already in the question, they're telling you this is a direct variation. A varies directly as B. We need to write this expression in equation form. So this expression in equation form will simply be A is equal to KB. This is a general expression. This is a general implication of this. If we want to write A varies directly as B, this is a general thing. But what they want is a specific equation connecting A and B. So we start with finding the value of K, the constant of variation. So we'll say KB equal to A. We divide both sides by B. K will therefore be equal to A over B. We have been told A is 12 and B is 15. We substitute these values there. So K will be equal to A is 12, B is 15. The highest common factor is 3. 3 in 12 will be 4. 15 divided by 3 is 5. So K will be 4 over 5. This is just the constant of variation. The equation connecting A and B will be, where is K? You're going to substitute it with 4 over 5. B. So this is the equation connecting A and B. I'll write part B there. We need to find the value of B when A is equal to 20. We need to make B the subject, so we have to take this term 4/5B to the left hand side. We multiply the multiplicative inverse of 4/5 on both sides of the equation. So we'll say 5/4 multiplied by 4/5b. So we do the same. 5/4, we multiply a by 5/4 on the other side. So what we do now here is we cancel out this, cancel out this, cancel out that. So we'll have b being equal to 5a/4. We substitute the value of a in this equation so that we just have b. So 5 multiplied by a is 20/4. 4 in 4 is 1. 4 divided by 4 is 1. 20 divided by 4 is 5. 5 times 5 is 25. 25 divided by 1 will give us 25. Therefore, B will just be equal to 24. I hope my audio was okay. So that is that about direct variation. In the next lesson, we're going to look at inverse variation. I hope you have learned one or two things from this video. If you're enjoying this video, give it a thumbs up, like it, and you can subscribe to the channel. Have a good day or evening.